Today on the Perception in Action podcast, how, when, and why should we be using variability in practice? What type and how much? A look at a new applied model. So it's time for a call to action. Hi, this is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Now on to the show. Hi everyone, this is Rob Gray from ASU and the Perception in Action podcast, back with another article review. In today's episode, I want to review a paper that attempts to do something I think a lot of people are looking for, right? How do I take the basic research findings, around, for example, variability of practice, and actually apply them, right? How do I know when to add variability, how much, so on, right? What type? So this paper is going to attempt to address all those questions. So the paper is Applied Model for Using Variability in Practice, and I thank the authors for sending me a preprint advanced copy of this. It just recently came out. So this paper starts with a background of understanding the research on variability of practice, right? And it starts with the idea that learning requires generalization, right? So we're going to learn in a very narrow range of cases, right? We're going to practice in a very narrow range of cases, and we need to generalize this to broader, right? Because broader range of context, because we're going to in competition. You're going to face things that you can't possibly face everything in practice that you can face in competition. Okay, so we can practice very few variants, but still successfully execute the non-trained variants because we generalize one trained variable distribution to a novel one. This is, I start with a problem here. The concept of generalization is a very cognitive information processing idea, right? The idea that you start with the one correct technique and adjust it for the different variants you're going to face in competition. This is something I covered. I'll talk about this more in a second. I have a blog post and I've covered in my book, first book, the adjustability versus adaptability role of variability, right? So starting off right from the start, the generalization, I don't think that's what we're looking for in ecological dynamics. We're looking for degeneracy. We're looking for multiple solutions. We're looking for ability to solve problems, not for taking the one way we learn it and be able to adjust that. Okay. They also look at types of variability, and they identify 4 different types based on this work by a person named Ravi. Numerosity is when learning is based on the numbers, examples, practice. So we could vary, if we're doing batting practice in baseball, we could vary projection speed, location, trajectory. If you're doing fielding practice, the more variance we add, the more variable the practice is, right? So if we have 5 different speeds and 5 different angles and 5 different trajectories, that could be high variability versus 2 of these, right? And I touched on this a little bit in my last episode with the volleyball, right? There was a very small number of variants, only 3 conditions, right? So that's what they mean by numerosity. Heterogeneity refers to how similar the movements are for the different variants. Okay, so in more heterogeneous practice, you have to do more different movements. Okay, so hitting a specific tennis ball to a target, right? If you're allowing for both forehands and backhands to make the shot, that's more heterogeneous, right? They're different than if you're doing only forehands. So we're not varying the number of conditions; we're varying the difference between them, right? Between the movements involved. Situational diversity relates to the environmental conditions in which the practice takes place. We could have the same movement performed in crowd, snowy, icy, open water, swimming, right? So we could have lots of different situational diversity. Important concept that they touch on a little bit is some of these are going to be task relevant, some of them aren't, right? Whether you're playing on a green or gray playing surface has no relevance, right? Unless it's affecting the visibility of the ball, which in most cases it wouldn't. So it's really task irrelevant. Okay. And finally, scheduling. That's the spacing or interleaving the practice, which is the bulk of the research is on variability practice, is really referring to this, how we schedule practice, not the content so much, right? So we're going to Are we doing block practice, serial practice, random practice? We're bringing in contextual interference here, which I reviewed a couple episodes ago, right? The evidence for that. So we have these different types. So the authors kind of point out so this is showing the different ways we can create variability of practice. I think these are somewhat overlapping, but I think it's useful. It is useful to kind of think about the different ways we can do it. And the next thing they do in the paper is they relate variability to motor learning theories. And they basically show, and this is something I've said before, variability serves a purpose in no matter what theory of motor learning you subscribe to. We've accepted that variability is good. From Bernstein's theory of repetition without repetition, we have schema theory, Schmidt's motor programs, dynamical systems, ecological dynamics, challenge point and optimal theory, which I'm not sure are a contextual interference. So we have all these different theories pulling, and they try to map on the different types of variability I'm talking about to these different theories, right? Which is kind of makes sense. But the key point is, right, no matter what you believe, I think we've come to the point that some variability is good. And this is something I've written about before, right? Where we differ is when and how variability is added. What's its purpose? Based on what its purpose is, it's going to determine how you add it. Okay. So Bernstein's theory is based on heterogeneity, right? Repetition without repetition. That's essentially what we need. Means we need a different solution to solve the same problem. Advantage for variable practice was also predicted by Schmidt's. We better learn the relationship. We better develop better motor programs, right? That's a basic idea that I talked about when I reviewed the contextual interference. We get more and enriched motor programs when we vary things. And we're talking about numerosity and situational diversity. Ecological dynamics, the variability changes the informational landscape of affordances and guides the discovery of new solutions. Numerosity, heterogeneity, and situational diversity are inherent in these theories. So they're trying to map these different types of variability onto these different theories. Challenge point and optimal theory plays a very close setting the right level of difficulty, right? This that they're bringing these two theories bring in the idea that variability changes difficulty, task difficulty, and motivation and things like that, and you have to get that right. So they've kind of tied this all together in a pretty nice way. Okay. Other things we can do, the contextual interference is where learning is presumed to benefit from the amount of interference that results from switching between different tasks. I reviewed that a couple episodes. The relevance of that to sport context, when we just compare the binary conditions of random versus block, is a bit questionable. Low to high, depending on whether we're going to, we get this traditional explanation that you suffer in the short term because you have this interference, but you get better in the long run. Contextual interference is an example of the scheduling type, right? So we're not varying the number of conditions or the similarity between them. We're varying the order and how they would fit together. Okay, so that's a kind of basic idea. Okay, and as I mentioned, here's one example of where I've talked about this: the how, why, and when we use variability in practice, showing that the two ways, yes, both it serves a place in all theories, like we said, but it's very different, right? And I call it adjustability versus adaptability, right? Do you start with the one correct technique, the fundamentals, and then teach people to adjust that to fit to different conditions they might face in practice? Or do you add variability to produce adaptability, to develop the person as a movement problem solver? Right? They're very, very different things in my mind, and you can read that if you're interested. Okay. So in terms of actually applying this and implementing variability of practice, right, they talk about the three key principles, right? The first is level of difficulty, right? So we know there's lots of beneficial effects of variability, but it also increases the level of difficulty when you vary things a lot, right? And this can get into issues of challenge point and optimal theory. That they're motivational and effects, right? It's variability of practice is not just for motor learning; it has motivational and things effects. That's something those theories have emphasized really well. One of the kind of the issues that I have with this paper, and it's going to come out as we go into more deep, is it's kind of a lot of these things start by taking a theoretical stance. They think, right, that, okay, variability is good for all. We can look at it. And then they say things like this: a constant or block practice would provide novice adequate opportunities for learning, right? So they're starting with the fundamentals idea that you learn, which does not fit with ecological dynamics at all, right? So, but anyway, you need to scale the variability to get the difficulty level right is one important point. The second thing, the important principle for how we use variability is managing expectations, right? Right, we need to keep the optimal. We have the enhanced expectations, enhanced learning. On one hand, and I've talked about this before. In block practice, people feel like they're learning, right? They're making gains, while others might become disillusioned in random practice, leading to less effort and engagement. Okay. You need to take into account the learner's motivation and confidence, right? When you're using variability, you can't just throw them into the conditions and if they're not going to respond. Okay. And the last principle they bring up is representative design. A third key principle for implementing variable practice: the task variation should be representative of the attendant performance context. In other words, training variations should simulate the contextual, typical information competitive setting, provide athletes couple perception action through realistic situations. Okay, here's one of my problems. I do not like this definition of representative design at all. Right? This is specificity. It's not representative design. This is, I keep bringing this up. I think, so to me, representative learning design, you're not trying to recreate competition exactly. You're trying to keep a small number of essential elements there. The information, right? The action fidelity, there's multiple affordances, right? These kind of things. Beyond that, anything goes in my mind. We don't, right? That's why practicing shooting with like in baseball, we practice with a larger pitchers throw a smaller ball than normal and a larger ball than normal, right? Those are not situations that they're going to actually face. So we're not trying to get them to be able to do something in practice that they're going to face in a game. That's adjustability, right? We're trying to teach them adaptability, problem solving. We accept the idea by learning to perform the skill with an object or facing constraints that you will never face in practice is beneficial, right? So I don't really like this definition of representative design. To me, they're talking about specificity of practice here, right? Representative design, as long as you have those key components, anything goes, including things you'll never face in practice. There's benefits to having to perform the skill under conditions you'll never face in practice in the competition, right? So that's the issue I have. So from there, they talk about this idea of regulatory and non-regulatory conditions. So they're talking about conditions that you can add that affect the specifics of the movement, while other things will not affect it only affect it directly, such as fatigue. Okay. So regulatory conditions, the weight of the ball, the length of a bat, for example, distance of a target, those are task relevant. They're directly going to change the movement pattern that you need, right? More force. Non-regulatory conditions could different flooring, different lighting. They're going to affect the movement pattern, but in a more indirect way, right? So that's kind of a concept they bring into this as well. Okay. All right. So from there, they developed this applied framework for using variability in practice. So they're trying to answer those questions: how, what, where, when, and why. Three key principles: level of task should correspond with the athlete's optimal challenge point, right? Manage athletes' expectations according to a practice goal. Task variation should be representative of the intended port, right? So, I already disagree with number 3, right? If you don't believe me, look at the vast research on differential learning, where you're going to have task variations that are not like competition at all. When does a soccer player ever make a shot with their arms behind their head or one eye closed, right? The purpose of variability is not to not to mimic a situation you're going to face it's to get you to problem solve, right? So there's the issue, right? So they've already, kind of leaned into one theoretical approach and ignored another, even though they're trying to remain atheoretical. Okay. So when to add variables. So initially, athletes must acquire the spatial temporal movement pattern, getting the idea of the movement, they call it, and learn to distinguish regulatory from non-regulatory conditions. So this is the fundamentals assumption, which last couple of weeks ago I showed doesn't seem to support. Need, if not all, attentional resources toward the execution of movement. That's an information processing idea. Consequently, an athlete should not only practice one skill at a time, should initially do so under conditions that do not require decision making. You're making me shudder here. We're talking about task decomposition and representation, reducing variability down. Once athletes have developed a movement pattern that allows for some degree of success, they enter the skill refinement stage. At this stage, varied practices should be reduced. Right. So this is the classic fundamentals idea. You need to learn the one movement pattern, then learn to adapt it. If the goal of practice is to maintain athletes' current skills, develop automaticity, theory, information processing in a skill or enhance expert success, decreased levels of variability should be used. So variability, again, it seems to be driven by these classic information processing ideas of the one correct technique, moving towards automaticity, things like that. Well, that interleaver should be spirited. Other suggests the amount of context should be individualized, taking into account the skill level of the athlete, supported by the challenge point framework. Levels of contextual inferiority be systematically increased by reducing the size of the blocks of repetition and moving to a random schedule as learning progresses. So going through these stages of learning. So, in ecological dynamics, we don't deny that you can't throw everything at the person. It's just the different reasons for doing and scaling are completely different, right? So you have different view, right? So this, this is kind of classic. So here's their model. Where are you in? Are you just starting out? You're getting the idea of movement. Then we want no variability. So we have the fundamentals assumption, right? You need to learn the fundamentals under prescription, low task decomposition, no decisions involved. Then we're going to plug it back in and we're going to refine it. This is where we, cognitive load to improve decision making, attentional load, right? So we're adding in things. So this paper for me, I don't know, what it's doing. It's an applied model of using variability based on information processing ideas. It's not like what I thought it was going to be when it started, a contemporary model that takes into account ecological dynamics, self-organization. It doesn't do that at all. It's very, very heavily information processing based. It's based on the idea of, using adjustability, right? So you can have a look at it if you want, but I don't think there's anything super new here. Here's a specific example for a tennis serve, what you can vary. These showing how, when to add variability and why. There also give a good examples of types of variability for different sports, alpine skier, soccer player. They divide these into non-regulatory and regulatory conditions, right? Ones that are, I would call these, a lot of these are sort of individual. I would put these in individual or environmental constraints, things that have a general influence. These are all task constraints that are going to require different. That's the way I would divide it up, instead of this regulatory and non-regulatory way. Okay. So that kind of sums up that paper. Like I said, I thought it was going to be one thing, and it kind of went into very traditional, classic ideas about motor learning, the fundamentals assumption, the idea of adjustability, the idea that you want to learn under essentially no variability conditions, no decisions first, before you add variability in, right? And like I said, there's this nothing wrong with that. That just recognize that's one way to do it. The theories that they cite at the start, Bernstein and ecological dynamics, completely different function of variability, right? So it has completely different. That is why there's no one general applied framework for how to use variability. It, like everything, depends on the theory of motor learning you prescribe to, right? That's going to determine how you use variability. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter @ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including a monthly coaches meetup, please head over to patreon.com/perception action. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.
Gone through St. Louis.